what I call digital project delivery. And I'm going to go kind of fast here because I want to be done by, I guess, 11:19, so time me here. That's just about me. I won't belabor that too much because you can look it on the internet, but I'm involved with ASCE and TRB and ASCE and some stuff. Map 21 law, we've all seen this. This is not the reason for it. This is just a piece of the puzzle, but it did go into law last year. I don't know how the language, I don't know specifically how the language got in there with the House Subcommittee on Highways and Transit, but I was told by Deke Smith of the National Institute of Building Sciences that they wrote the language that they gave to the House Subcommittee to put in there. Now, whether that's true or not, I don't know. That's what Deke Smith of NIBS told me. But there it is. It's advanced modeling technology. But it's really not about technology. It's about a concept. You know, there's no specific product in there, no specific software. It just talks about we want to do something. And I'll be the first to say I look at this, and it's probably a little clumsily written, right? But it is in law. So somehow we got to take this, you know, whatever this clumsily written language that's in national law and transform it into some kind of clear philosophy that we turn into practice, right? So I'm going to have a basic vocabulary. A model. A model is anything that we use to have a simplified representation of reality. It's not 3D, it's not 4D, it's not all this stuff. It's just whatever we use to simulate reality. Because reality, the real world, is fully integrated but infinitely complex. Mostly, almost infinitely complex. We're not getting into quantum physics. But it's fully integrated. It's all there. We don't need, the real world doesn't need to describe itself. But when we try to understand the real world, whether it's visualizing transportation or design and construction or whatever, we got to simplify it so we can get our minds around it. So it's like we have this model, and sometimes it's too simple. Sometimes we leave things out. So the idea of a model is it should be complex enough just to get the job done, but simple enough so we can still wrap our minds around it and use it in an efficient way. It's because the system, the real world is a system. So anything we do out there, whether it's transportation, whether it's design, construction, operation and maintenance, we are modeling the system. We are trying to simplify the infinitely complex but fully integrated real world. So that's what I say. It doesn't mean 3D. Model does not mean 3D. It means anything that we use that is a simplified representation of reality. And in transportation, some people might disagree with me, there is no 3D. There's a 3D final project, but in transportation, we're sort of 2.5D. The building people are 3D, because, it goes in space, but, we're still dealing with profiles, which are parabolas. That's a 2D mathematical concept. We're dealing with horizontal curves and spirals. So we have two-dimensional math that describes components of our projects, and it eventually, gets built in 3D. But in terms of modeling, I'd say we're kind of 2.5D. It also kind of goes to, the shape of the world. We're not, our coordinate system doesn't have 90-degree corners. It kind of wraps around with the world. So that's what I mean by the model. And so model-centric design is everything goes in the model. In the old days, we were taught, calculation paths, things like that, red pencil and yellow highlighter, all these practice methods that literally date back to the 1840s when the blueprint was invented, or the 1950s when the diazo print was invented. Who remembers the old thing with the ammonia smell and run the thing through, right? So now we got a whole new world. Everything's in a model, but our brains aren't there yet. Our brains are still about documents. Well, where's the document? We have document management systems. It's like, why don't we have a data management system, an information management system? Because we're still thinking about this thing. It's a document. Well, the document's not really there. It's just an analog image that the computer puts on a screen, but there's real information behind it. So that's what I got to change in digital project delivery. We got to change about how we think about how we deliver this information. Because it used to be the model was ink and Mylar. And that was our technology. That was the best technology we had. And so we had all these habits and practice methods developed over generations, right, that focused on the model being analog. But now we have enabling technology. The technology is not the solution. Technology is an enabler. So then we can take the enabler and we can find a solution for it. But the solution is found in our behavior. It's found in our psychology. It's found in our organizational practices, what some might call this cognitive dissonance, right? So we can throw technology and standards and things like that against the wall all day long, and none of it will stick until we change the way we think about this information. So it isn't about the software, right? The software is a tool, right? that we need. There's certain things we can't do without it, but the software doesn't define the practice. Our approach to it defines the practice, and then we look around for whatever tools around us, software, hardware, whatever the vendors can provide to help us in we making the solution to our project delivery processes. So sometimes you try to throw it in and do a hybrid practice. That actually makes it worse, because now you've got the cost of the technology and the lethargic nature of these old processes. You'd have been better off sticking with the old technology and the old process. So with new technology, we have to rethink entirely new processes, entirely new practice philosophies, or things will just continue to get worse. And I think the 2004 NIST report says we spend like 40 to 60% of all our time and money and cost and professional fee in design and engineering, producing non-interoperable analog information. That's a lot of money. 40 to 60% of all professional money, right? Of all the stuff that our firms get. So we need to change our thinking. We need to change our thinking about what are our productivity needs, what information really goes out. Maybe information we used to send out is now obsolete because they don't need it anymore, but we continue to do it because that's how daddy did it and granddaddy did it and great-granddaddy did it. We got to get rid of that and think of new processes. We need a new language. We got these old words like, oh, you need a standard, you need a thing. You say you need a CAD standard this, or you need to document this. These are old words based around old concepts in our mind. So we need to like clean out our mind, come up with new language and new words to describe a new way of thinking about delivering things in a digital world. Even the quality assurance. How many people have dealt with the red pencil and the yellow highlighter, right? We're doing all this stuff digitally. You know what we do? We print it out on paper and somebody marks it up and, oh, I don't like that line weight or that font. I've never seen a line weight or a font cause a single dime of construction claim. Seen a lot of bad data do it, right? So we need to change our quality assurance because that's how we control our professional risk. If we can't control our quality, we can't control our professional risk. Well, that's how a lot of us learn, right? That's how I was taught, basically the old curmudgeon. This is the way you do it. Don't argue with me, don't ask questions, right? The more you're doing quality assurance of the design, you justify your salary by making more comments. You only came up with 10 comments. I came up with 100 comments, right? Well, it's like, what if there were 10 comments on how many strands there were on a beam and the strength of the concrete, and my 100 comments were, I think your font in your title block is the wrong font, right? So we need to change, right? Or we're going to drive ourselves into the loony bin. Some of us may already be there, right? So we've got to change. So that's what I mean, 40 to 60%. So it's like we got this wall of legacy analog practices, and sometimes we get around here, we say, oh, I want to do, give you show and tell of a project where I got around it, I got over it, I dug a hole, I found workarounds to basically use this technology even in a practice model that is obsolete. Well, what's wrong with that? It's like, well, is it commendable that the person found a workaround? Or is it sad that they had to work around an obsolete practice philosophy? So we got to change the practice philosophy. Then we don't need all the workarounds so that people can do the show and tell of their project, which is commendable. It's commendable they found some sort of rabbit hole through the maze, right? But we got to get rid of that. I mean, literally, it's no less than changing an entire profession. I'm talking about the civil engineering profession. And I mean it seriously. This requires the complete reworking of an entire profession. So it's got, TRB can be part of it, ASCE, it's got to come from ASCE. We're going to start a new digital project delivery committee. So anyway, out of that NIST report, this is 2004, they estimated $15.8 billion per year. $15.8 billion per year. Now granted, that's like 0.1% of our national debt. So I guess in terms of Washington D.C., it's like $1 billion, $1 billion here and $1 billion there. Pretty soon you're talking about real money, right? But to me, $15.8 billion a year is a lot of money. That's a lot of, that's like, the combined budgets of several state departments of transportation for an entire year. And when we're wasting that money in the engineering process, not just design engineering, but construction engineering and planning, operation, and maintenance, producing information and looking for information, verified information that is not compatible with each other, it's not interoperable with each other, and gets lost all the time, and it gets in different formats, only because, and the only reason we've made it that way is because that's how we were taught to do it. That's how our brains are thinking about it, and all that money's going down, as the Brits would say, the loo. So that is a lot of cheddar. So the question is, how do we change? Now, that's in the design process. Imagine how much money there is in the construction process. I don't know if that NIST report looked at that. It's interesting to reference it, but the NIST report is only a tiny, tiny bit of what's really going on out there. Think about what's going on in construction. Now, the contractors are more aggressive about doing this, and I say because contractors aren't paid by the hour. We professionals, we get paid by the hour. We're paid by the hour. How much incentive do we have to innovate, right? We come in, we get paid by the hour, we tack on a multiplier. Matter of fact, there's consulting firms that say, well, you got to get your utilization rate up so we can tack on the multiplier and get those revenues in so we can pay for the corporate overhead. Well, imagine a contractor, they don't get that. They get paid by how many square yards of pavement they put down or how many cubic yards of dirt they get in. So because they're not paid by the hour, they innovate like crazy. So maybe part of this change is even changing the model of how professionals are paid so that we're not paid by the hour, we're paid by the value we create. And that's a big change too. Imagine the heresy of suggesting that we should change the model of how we financially compensate an entire profession. And I'm sure somebody out there has already put in a hit on me right now. So that's what I want to share. And actually, I guess I'm a little bit ahead of time, but that's okay because we do have a lot packed in here. And the less I talk, the more we have for questions. So we got to start with our own processes. It's like, we got to be sustainable, and it's like we're pontificating to the world about how it should be more efficient and better. Like, we got to start at home. We got to look at our own internal processes. We got to look at our own house and say, how do we change, whether it's the civil engineering profession or the architectural profession or the surveying or GIS or even urban planning, and look at how we do things and clean that up, and then say, now that we've done that, now we look outside and see how we can apply it. So that's the evolution. I think right now we're kind of in the round trip engineering a model. We got to remove the waste from engineering. I won't get into this is the lean theory. Won't get into too much of that, but the pictures speak for themselves. But we got to change things. We have to change our ways. We have, to quote Pogo, we have met the enemy, and he is us. Anybody ever read Pogo? We have met the enemy, and he is us, right? So that's all I got. I hope it was informative, and I hope it didn't put anybody to sleep. And now we'll get ready for the next speaker.
Thanks, Danny, for speaking to the demise of our industry. Next up, we've got Philip Meis from Utility Mapping Services with a presentation on ASCE Standards Consensus Activity for Utility As-Built Records. Phil, a little bit about Phil. Phil received MS in 1986 from Colorado School of Mines in Geophysical Engineering and a BS in 83 from Iowa State University in Industrial Engineering. He's active with TRB, ACEC, AASHTO, and ASCE, and currently serves on a National Academy of Sciences Strategic Highway Research Project to standardize use of utility conflict matrices. Welcome, Phil.
Well, I want to really compliment what this guy said. He's like a whole pep rally packed into one Texan here. If I could bring you along with me, because that's a beautiful prelude to what I'm going to present here. Because what we're trying to do is change the way things are being done right now as far as utilities go. And a lot of the things you mentioned are exactly the issues that we're facing in the utility world. So I am the chair of a standard committee, and I'll use that archaic expression. I don't know how else to describe a standard, but what we're trying to do is develop a new method for collecting and administering and exchanging utility data, or as many people call as-built records. And I gave you a little background of how that evolved, or why we're doing this, and the scope of our effort, and what we plan to deliver, who's involved. We have a very good cross-cut of industry, design people, of construction, people in the agencies, the federal agencies, and the National Geodetic Survey involved. So to help us to nail this problem. The standard is for newly installed facilities, and it's also above ground and below ground. And our objective, one of the key objectives would be to provide something that public agencies can use, and they can turn and hand it over to a utility company that's boring something into the right-of-way, and they can say, here, when you go out there, just collect your information to these standards, and then when we want them, give them to us in these standards, and just make it easy. And to emphasize, this is for new infrastructure going in the ground. There is an ASCE standard that exists that's been around since 2002, ASCE 3802, that is for the collection and depiction of existing subsurface utility. And Jim Ansbach, he'll be talking later on. He'll probably mention that. I'll mention it here briefly too. So what we have going on right now, we work in about 15 states, and this has been just a gripe of mine because we have to work with this garbage information, all these analog pieces of paper that are out there, and try to turn it into something that's usable for design and construction. And a lot of times I see, even if we do create the information, we're forced to push it back into a 2D or a PDF file, and it's not being used leveraged like it could be. But so all agencies right now have a practice where they say, go ahead and you can go in our right away and collect accurate information. But nobody's ever defined what accurate is, and that means anything. And they don't have what information needs to be collected. So this would be your standard permit requirement, and it's very little direction on how to go out and collect the information. And so, we've kind of created our own problem. So here we got archaic practices, clumsily, what was the expression used? Clumsily developed practices that haven't been updated. And the information that you get are just schematics. They're not tied to any datum, and they're really incompatible for any kind of the tools that we have out there for modeling and depicting and doing all kinds of good management practices, planning and construction practices. This is an example of, and I'm not picking on Utah, but this is one we submitted just last year for the Utah DOT, and it's an as-built. It's an as-built for utilities. We did a full subsurface utility engineering investigation using ASCE 38. Had wonderful information, all the attributes, size, ownership, quality level of the information, and even 3D data. And we basically had to strip all that stuff out at the end of a project and create a PDF file, black and white PDF file with all the information stripped out. And that was our submittal at the end of the day. And that's for the next person to pick up and use later on. So this is and here's an example of, well, it's a quest record, but you have to be a cryptologist to understand. This is the type of information that they're collecting for their usage and handing out. And it's really of not any use. So why is this different now? Why hasn't this, this seems like a no-brainer, Well, before, 20, 30 years ago, we didn't have internet, we didn't have deregulation, and we had Ma-Bell and just a few utilities. Now we have deregulation and a e-commerce boon, and also cloud data management arising. And so there's all kinds of infrastructure in the ground. You just can't believe it. That's going in all the time. You want your 5G, 4G, 5G in your phones, and you have to have high-speed cabling to connect to the cell towers to get that type of. So there's a real initiative at this time for a lot of telecoms to be putting new fiber in the ground to replace our capacity for the old fiber is already being used up. The boon in e-commerce, you have banks and all kinds of. This is Informatica. I met this guy at a conference in Texas, in Dallas, just about a month ago, and he writes software for businesses to manage all their information in the cloud. So what I want to get at is from a liability stance, we as engineers are, developing plans and delivering projects, and if a cable gets broke, and you've disrupted Wells Fargo Bank on the corner, and some, all these transactions have been, stopped, you're talking about major impact, and a lot of liability. So this is the increasing risk is phenomenal. And you might as well, and everybody gets named when a cable gets broke. In fact, I couldn't help, Jim Ansbach just walked in, and he's involved with a number of litigation cases where things happen, and everybody gets the finger pointed at him, especially the professional. So what we have to do is, here's a case here where Northwest Airlines got their cable cut, and it shut the airline down for about a day, I think, and that litigation is still ongoing. You can imagine the cost. So it's we've got utilities all over the place. This is a project we just are working on in Portland, Oregon, and Vancouver, Washington, and it's the Columbia River crossing, and this is a CAD depiction, and this is just showing the utilities. Everything else turned off here, and this is kind of congestion we have out there. And it would be so nice if that information was collected accurately when it went into the ground in the first place, so we don't have to go back out and create. You talk about millions of dollars spent. We have to spend the effort to go out and recover what's out there and bring it back into a usable format is incredible. I mean, compared to what, if we just kept track of it when it went in the first place, which I can't even think it's fractions of a penny on the dollar that's in comparison. And it's a living animal, too. I mean, this is, when we were working on this project, there was cable being moved, ducts being moved in real time, and we had to go back out after we went through this area and had to come back. So it's really out of control as far as how the DOT is managing. So I'm going to have to hustle up here a little bit. So we can't ignore the 800-pound gorilla. And, I left out this is the worst case scenario if you have bad utility information at the construction. This is why your contractors are really keen on trying to figure out better ways and are taking, they would love to have this implemented. So what we're doing is we're going to be stemming from old existing standards. I shouldn't say old. This is a Canadian standard, CSA 250, was just published 2 years ago in 2011. This is a standard for new infrastructure going in the ground, but it's primarily for buried. ASCE 38 is for existing, and we'll also be using a number of other standards that are out there, as well as for spatial and visualization and bringing it together. This is the standard I mentioned for existing. Now, we don't want to get confused with that. This is for existing infrastructure, and it has a very good quality level A's and B's, and so you can tell if your data is, usable or not. And then this is the Canadian standard that was developed, and they came up with a table for actually applying an accuracy, a spatial accuracy to the information. We're going to go beyond just the spatial aspects. We're going to look at the attribution and design parameters that are needed for design development and project delivery. And the idea is to get more sophisticated. If we have good data, we can, now you can start avoiding impacts to a lot of the major infrastructure during your design development. You can do sensitivity analyses and things like that. So this is a cross-cut of our industry and our representation. We got Corps of Engineer, we got industry, construction, designers, we got CAD, people from CAD industry involved, so it's a good cross-cut across the country, about 37 representatives, and we meet monthly right now. And again, we're getting away from the term as-built. That's an old term. We're inventing a new expression. This is going to be the standard for the collection, administration, and exchange of utility installation information. So that's kind of tells it. As-built has existing mindsets and legal implications that are tied to it. So state statutes actually define what an as-built is, and we wanted to get away from anything that was, try to change the way people think. And again, it's, these different activities in the collection. We're looking at, directional drilling, trenchless activities, open cut, looking at different, the spatial aspects as well as the attribution, use of RFIDs and other remote sensing technologies. The administration, we're going to look at the legal implication, if something happens later on down the line and they're using the data, how is that managed? And you want to make sure that responsibility for the information is clearly defined and identified with the data submittals. And you also want to be able to exchange the information to push it out into XML formats and so we can bring it into all the wonderful platforms that you people are developing here. And this is a clash detection. This is just an example that was shown last week in North Carolina at the ASCE conference where, if you have good data, you can automate and find out where things are impacting and in design and instead of with a contractor and a backhoe. And again, I was mentioning the beautiful depictions, and we want to be able to accurately represent what's above ground and underground in our models. So that's about it. I think we're looking at, we had our inaugural meeting in May, and I'm here to just basically tell you that we are working on a standard. It's an ASCE standard for the Construction Institute, and our plan is by 2016 to have a published standard out that's available for people to use. And if you have further questions, by all means.
We'll have enough time here to field some questions at the end for everyone. All right. Lastly, I'll be sharing with you how to leverage automation within this workflow. Let me give you a little bit of background to myself to tie into my education and experience and why I'm going to be sharing this content with you this morning. Chris Johnson, I work for CH2M Hill in Milwaukee, Wisconsin. I got a BS in mechanical engineering, and I've been doing CAD since I was a sophomore in high school when my dad bought a little, I think it was a 286, and me and my brother sat in our basement and learned how to do CAD drawing cars and tanks. My career has afforded me the opportunity to work as lead technician on the 3 mega projects in Wisconsin. So I've been a lead technician. Now, 3 years ago, I had a conversation with a project manager that went something like this. Our client wants BIM. Can you give it to them? So my job over the last 3 years, in part, has been defining expectations and trying to deliver solutions to meet those expectations. What I'm going to share with you today is probably the single greatest asset that I've seen to being able to deliver and meet these expectations. So up front, I just want to hit visually on the primary takeaway this morning. And this really hits on what Jonathan spoke about this morning as far as just throwing something over the wall. It was said in a number of different analogies this morning with going around the wall or underneath the wall. And I'm speaking of it in another analogy, a gap. And I propose to you that custom automation will help you deliver VDC or CIM technologies today in a way that would take years without it. And I'm going to touch a little bit later on about how this is going to work me out of a job. So here's how I'm going to spend the next few minutes sharing this content. I'm going to first define automation and give you some examples of custom automation. I'm going to share with you a project toolbox application, which is essentially a Google search engine for tools. I'm going to follow that up with some metrics that I've collected from that toolbox over the last 3 years, and then finish it up with some actionable items. If you're asking the question, okay, this is convincing, I see the value here, what steps can I take next to try to leverage this? Okay, so automation in general, when I use the term, I'm speaking to a mechanism that facilitates repetition of a task or process. Very simple. With gears, 1 turn in here makes 10 turns out. Now, that's general. There's a number of examples of automation. You could speak to it in terms of your native CAD or GIS platform, and there's out-of-the-box capabilities there. You could talk about third-party solutions that help you deliver automated solutions. What I'm going to focus on this morning is custom automations. Scripts, such as those written in Visual Basic for Application, macros, Lisp routines, that enable automation within and between applications. And I'm using those words specifically, within an application and between applications. An example being a CAD element that can be batch processed using variables defined in a spreadsheet. So just a few words on the theory behind this approach. And again, I'm repeating a lot of what you've just heard in the last 2 presentations about a paradigm shift in our industry. CIM is to CAD what CAD was to paper. Now, like I said, my dad came from a similar background 20 years ago. He got a BS in mechanical engineering, and he was a board drafter for a number of years. And you know, one of my favorite pictures of my dad in his career was going over to his office and seeing a room full of boards and electronic erasers and brushes, and he is a dead eye with the rubber band. He brags to me about how he can take one of these rubber bands, and him and his buddies would set up cups, you know, several yards away, and he could knock that sucker off of a signpost. So this is a graphic to just represent the trend of where we're going, from pencil to plotter to model. Okay, so this brings me to the premise of my presentation, speaking about the gaps. And there's a couple words up there that speak a little bit to why I would explain why there's a gap between what technologies and efficiencies are attained on a project and what technologies and efficiencies are available. And so you can see here how those specific facets, scope, contract, and schedule, are hugely disproportionate or in tension with client expectations. And here's where I just want to kind of touch a little bit more on planned obsolescence. New wine needs to be poured into new wineskins. Right now, there's a lot of energy, excitement, and interest in the technologies regarding CIM, VDC, BIM, and other acronyms. And I fully expect that we will no longer be talking about this in the coming days. And I would propose to you, it's kind of similar facet to if we were in a room full of multilingual folks here. In the beginning, if there were a room full of native English speakers and native Spanish speakers, there would be a high market share for translators. They'd be in high demand, and translators would have a lot of business. But the longer those people occupy the same space together, the less need there will be for that vocation of translator, because they will learn how to speak their own language, each other's language. And so that is the role that I see custom automation playing, and why I say that this addresses that shooting data over the wall. Because at the end of the day, we're just talking about data. We're talking about model in all of its various forms. And because it's electronic, because it can be manipulated in ways that are repeatable, it then just becomes a challenge of translation. How can we get data, valuable data, from one format to another? And that's what custom automation can give us. So now I'm going to turn attention to some specific examples of some tools that have been used specific to the CIM and VDC. there's a lot of other tools that are in this context of custom automation, but I'm going to share with you some that are specific to CIM and VDC. Okay, so model generating tools, a few model generating tools. One I call Model Generator, and this generates individual CAD models from each proposed roadway surfaces. And I put in there it took approximately 20 hours to develop. Example of this usage, for one of the projects in the whole zoo interchange program that I'm working on, there's approximately 180 surface files that are being designed by 4 teams, each representing a leg of the interchange, each responsible for a leg. And there's about a half a dozen to a dozen different designers that are maintaining those files. Manually, it takes about 30 seconds a file in order to generate each of these. It's very quick. But over 180, you can see where when this is brought down to 5 seconds automatically, that at one shot, there's about an hour and a quarter saved per use, 4 times used by project ID over 15 projects, and we've got 2 weeks worth of time saved to do this one task. Another example of a custom application for generated models is Drape Utilities and Element Converter. And these tools generate 3D model from a 2D plan by draping elements to surface per a mapping file. It took approximately 1 to 2 weeks to develop, and the approximate metrics there is the first time that this was done, it took about 500 hours manually to take the tens of thousands of utilities, and even to get close. I'll be the first to admit that both of what we're talking about in the products of these existing utility as-built, as Philip can attest to, what we were able to produce was a far cry from what is desired to achieve as far as accuracy. Nonetheless, there is value in having an approximation of a 3D utility file when it comes to doing clash detections and identifying the high potential for risk. And so after the 40 to 60 hours were invested to create this tool that essentially takes that 2D file, and it's a spreadsheet database that's got owner and assumed depth and conduit size, as well as the 3-dimensional representation of what was otherwise a two-dimensional cell. And we were able to cut that into simply just an hour worth of turning the crank. So that's an example of one of the high returns on investment is when there is a large number of crank turning that simply doesn't need to be done by a human because it's a matter of something that could be clearly defined in a repetitive task. I'm not saying anything that you guys don't already know here. Another example is a model of model modification tools is symbologized components, which this sets the level and color of model elements according to the style assigned them in their authoring design application. So here's an example where it's a very fair question. Okay, there's an application that was built in order to take some metadata that was in the native software and simply symbologize it according to that. Well, couldn't the native software do that out of the box? And the answer is yes. The native software that the designers were using could have done it out of the box. Here's an example of just how a significant facet, the scope, the schedule, and the software familiarity with the design team is. The design team was already one pant leg into putting on a pair of trousers when the need arose in order to do the clash detection and make it known that symbologizing elements in this way would be useful. So the question of whether or not you could go back and model it differently so that you could output it in a way that you wanted, that was out of the question. So this application fill that gap to be able to deliver it in time. Here's another example of where, okay, the model was to be shared, that was done in design with the construction team, but the construction team did not have familiarity with the design application or access to it in order to leverage the model in its native form. So it was delivered in a 3D PDF that they had access to. Well, the question at the construction team meeting was, it would be very useful if we could identify what actual structure ID I'm looking at. And so this is a custom application that symbologized, again, the elements according to their structure ID, so that, as you see in the blow-up of the picture, when an element was selected in the PDF, they could then discern what pipe structure that was. The last example here is a pavement marking data analysis tool. So here a spreadsheet was used as the source to define the symbology and for annotating as well as quantifying. And so this provided us that consistency that could then be automated and the efficiency gained from it. Okay, so some specific examples. Now I'll turn my attention to Project Toolbox. So this is a searchable interface for all project tools. Like I had mentioned before, it's essentially a Google search engine for project tools. This is something that I developed 3 years ago because as I've been giving monthly CAD workshops in order to share amongst a big project team what tools are available, I can't tell you how many times I heard the term, well, I wish I would have known about that last week, or boy, that would have saved me time. So it wasn't even a matter of solutions that couldn't be done, and it wasn't even a matter of solutions that weren't already there and in the same local area network that they were working on. It was simply just a matter of connecting them with the awareness of it. So, hence the Project Toolbox that has been recording the usage ever since. Now, these metrics can be used for a number of things. Here's 3 uses: to identify and promote useful tools, to quantify efficiencies gained, share that with stakeholders, your client, as well as to identify potentially helpful tools. So now let me get into sharing with you some of the metrics. Here, this is just a graph of utilization over time, and it looks eerily familiar. It's the same shape as the diffusion of innovation, S-curve. So you can see here 3 years ago, what started really, really slowly with the early adapters eventually gained momentum and to where now, so this is the current project team size. And so that difference then to why it actually collected approximately 130, 140 hits of this tool, and the current project team is 100, there's turnover in the team. So this just shows that the entire project team has been utilizing this tool. How many users are using this daily? So this is a graph of the number of users that are using it every day. And so you can see here similarly, about a year and a half into its creation, a year and a half, 2 years, it really jumped up. And 10 to 20% of the entire project team are using this interface daily that's connecting them with over 200 custom tools. Project team utilization, how frequently users are using. So this chart shows the average daily use per user. And you can see here that it has been increasing ever since its start. And this really, I think, paints a thorough picture of its usage. Those are actually from 0 to 250. That's actually just how many times something is being searched or used every day. The green on the bottom represents how many times somebody had looked for an application, and the blue with how many times an application was actually used. And this paints a really thorough picture that there's a sustained benefit over time. Okay, so I'll show the last few slides here, which is the top 40 tools. And so just organized according to total usage. This can be used to identify what's the most helpful tools that are being used now. This could also be used to show what tools are potentially being underutilized. So I've leveraged this in some of my monthly workshops, and you can see here identified by the high frequency of use but low number of users. There's a few tools here such as selection tools, raster modifier, PDF replacer, and SDB utility structure. These are tools that then I'll focus in on to share with the team so that they know, hey, a few users are using this a lot and finding a lot of value with it. You might find value in it too. So these metrics can show literally thousands of man-hours of time saved. This is quantifiably less money and better quality. Just the top 5 alone, when I conservatively estimate how much time this is saved, it came in over 7,000 man-hours saved. This is compared to a couple hundred to develop and maintain. Okay, so if you're asking then, how can I initiate this? Encourage and equip your lead technician to pursue developing automation tools to solve project challenges. Couple action items. Identify the automation lead. Support, meaning with dollars, development, either overhead. Some of these things were overhead. A lot of these were project billable. Host regular workshops to share project efficiencies. I do ours monthly, and there's approximately 20 to 30 people that participate. Build off of existing code. There's just a plethora, a treasure chest of existing applications already that can just be tweaked a little bit to save hundreds of hours. And finally, make sure that these tools get shared and make them accessible to your team. Thanks for your attention, and with that, why don't we have Danny and Phil come up here and we'll take any questions that you guys have for us.
Hey, Chris, before you leave.
Yes.
I didn't hear exactly how widespread you said the team that you're trying to reach with your tool set. Is that a local thing or is it national or?
It's a local thing primarily, and there's been a little bit of movement into sharing those with regional offices. But to be honest, as you could see there, that chart, it showed about 1.5 years, 2 years. So this is 1.5 years or 2 years that it took to utilize this application. But that's with a team I've been familiar with for 5+ years. And so what I'm finding is that the FaceTime that I have with the local office and those monthly workshops are what's making that something that is now a go-to. But in regional offices that I've shared it's while it's being shared, it hasn't been utilized in the same degree.
I have a couple questions for Danny. You mentioned, I'm a consultant, you mentioned how you would change compensation for engineers. Can you give me a couple ideas how you could realistically do that? And then the second part is, if you can, how do you give the carrot to the consultant by balancing profit versus efficiency?
I would say it's got to be a tight scope. You have to, the requirements have to be known. So there are times when you want to pay somebody by the hour. In that case, where you don't know what you need. You just want that person's time to help you walk through a problem. But if the scope is known, then you define the requirements and say, I don't care how you do it. Let's come up with the value it is and what we pay you, and let you figure it out. Just like we do with contractors. Here's a price. You figure out your means and methods. So so that's how you get the innovation. Now, there are political things in it. Suppose there's a public owner that's like, well, I don't really care how efficient they are. I just want to make sure that all the people that are being paid live in my constituency, right? I want to make sure that they're not shipping the work out to Vietnam or Hong Kong or doing sweatshops somewhere. They're trying to see not the value of what's being delivered, but where the money goes. So there are some political issues in how professionals are paid, but I'm just looking at it from the point of the innovation. So if the scope isn't tight, which means writing good requirements, not just, a bunch of typical boilerplate contract language, but, you look on Wikipedia, what constitutes good requirements? And you write those good requirements, and you agree that's what you're going to deliver, and you agree on a price, and then let them go. But it's to get that psychologically out of people is tough. This morning, right? We had it's like an innovation. We're going to do the 30-second thing and basically an ad hoc standard of line up 5 people deep. So that was just a simple requirement to save time and effort. Not hard to understand, but what does the psychology do? The psychology says, oh, I'm going to sit in my seat. I'm going to hang up there until my name is called. I'm going to walk down and make the audience wait a minute. So even though it was a simple standard, an innovative standard to save time, which is not hard to understand, it conflicts with the psychology, which is the psychology of, well, I shouldn't come down until my name is called, or I shouldn't, I want people to, whatever it is. I'm not Dr. Phil, but until we solve that, all these other technical things are unsolvable.
You had a question?
Yes. This kind of goes back to the user graph that you were showing with the statistics. It looked like obviously there was about a year and a half or so, with a relatively few number of users and things probably looks like around the end of 2012, beginning 2013, things really took off. Was there anything like different with the way that the tools were being promoted or being accessible? I mean, there's some kind of change that caused that behavior change, or is that just a natural outcome of just the adoption curve?
I've been asking myself that same question ever since I've seen the data. What happened then? And I don't have any strong data or reasons to believe that there was some things in specific that I did or changed the way I did in order to do that. The best explanation that I've got to date really is, if you Wikipedia innovation diffusion, you see a very similar phenomenon going on where it just takes, going to Danny's point, it's a psychology change, and that represents the change in the rate of adopting a new paradigm, a new innovation.
It's a question for you, Chris. The slide that you showed with the 3D representation of utilities,
Yes,
you mentioned that you moved from 2D to 3D,
yes.
right? What sort of assumptions you made
Mm.
in transitioning from 2D to 3D, and what do you use that product for? Was it visualization or design or a combination or?
Great question, great question. What were the assumptions? Essentially, it was a spreadsheet that was laid out by utility, which in this case usually was owner. So whether it's AT&T communication or Re-Energy's electric line or fiber optics, on the project's team was a utility coordinator, and he's been doing this for 20 plus years in the region, and he's able to provide some, I'm going to say, very good assumptions. And now very good is taken with a grain of salt when we're talking about utilities here, but assumptions such as, okay, even if you look at the as-built and it says it's X deep, I'll tell you, Chris, right now it's going to be between 42 and 46 inches deep, and this is 2-inch conduit. So it was basically a spreadsheet that lists out by utility type what the depth of it was, what the size of it was, and then in the case of a three-dimensional item like a light pole, whether it had a 2D analog, which was like a single or a twin light pole, and there was a 3D block cell developed that just mapped it. And what was it used for? It was used primarily for clash detection. And it was used for existing and proposed. So for instance, lighting, signals, FTMS, and planting. The teams were designing in 2 dimensions, and it's just a matter of draping them on the proposed surfaces, for instance, planting. And so then those were used then to compare and do clash detections with like the root ball of a plant versus drainage, and it identified some pertinent clashes. But here's where the caveat is that when we sat down at a round table with all of the different component leads, it's like searching for a needle in a haystack when it comes to these utilities at the level of detail they're at, because I might come up with 1,000 different hits, only 5 of which might be of value, and it needed the discernment of the utility coordinator to say, okay, stop, let's take a look at that one.
Hey, Chris, do you have in-house programmers who sit down with non-programmers who have an idea?
Great question. How in the heck does this no, well, we have hacks. I am a hack. It's because I've been interested in this for so long, I am now kind of wearing part of a developer hat. And so I'm the primary developer in-house to do this. But I have been training staff, and I have another person that is now highly fluent in programming. And every time we have an intern or co-op, that's part of what I train them with, is developing. And they are very quick to pick it up, and they'll develop their own applications. And so I was just in Michigan Tech talking with the professor the other day, and he fully agreed to me that how crucial to students developing language is to innovations. And I could go on and on about that.
So you infect them with the hack?
I infect them with the hack, yes. Yes, sir. And we're at 12. If somebody is here from the next session, feel free to give us the boot.
Chris, this question is for you. Could you expand a little bit more on the project Toolbox? Was it a website? Was it strictly internal? Or is it something that we can access, the general public can access to the internet?
Good question. So it is a tool that I developed on project time. So it's a company tool that's used in the project office. It was a dream of mine and a desire to have this be something that ultimately, let's make this Wikipedia. Let's share this. That's what I would love to see it happen. And I've reached out to a few vendors to see if they would fund me to make it something that you could leverage the cloud for this. But right now, this is just an application that is shared locally or within the office.
Question for Philip. You mentioned about the new installed utilities, and I don't think anyone disagrees with the 3D, but trying to marry that with the legacy of 2D information for utilities that we had for how many years. I see 2 camps where a person gets overwhelmed, or a DOT gets overwhelmed and says, I'm not going to 3D, or another person says, well, when you get 100% 3D, then I'll talk about it. And so you have this transition, and I think people are lost in the transition. Do you have a game plan of how to get someone with good 2D data or even schematics and get them slowly going to 3D as they do a project or as they have money? Because we always want to shorten project schedule time and we want to reduce costs, but we want to get you to do more work.
Right.
How do you have a transition plan to get from A to B?
Well, you have to demonstrate the value of going to 3D during project development. And there are tools that are evolving right now that let you actually collect information, existing utility information in 3D. We do what's called a subsurface utility engineering process. And that involves going out and collecting the data. And so you're taking record data. You start with the record data, and then you do a surface reconnaissance of all the surface facilities, and you associate them with the records. And then you go out with geophysical equipment and map everything out in very good detail in 3D. So on a project-by-project basis, you can have very good data in 2D and in 3D for your project development. And then it's a matter of getting that data leveraged. So you can demonstrate how much cost savings you've given not only to the project, but maybe to a gas distribution company where you've been able to avoid moving some of their facilities and you can quantify that. You have to get them involved. Yeah, go ahead, Jim, you got your hand raised.
I was going to say, we're going to go over that in more detail in the session this afternoon, so some
Yeah.
of those questions.
That's a good question, though. It's an educational process. You got to show everybody how it works.
The follow-up to that is USA. You have a lot of information being collected, and it stays with just that one project.
Yeah.
Then you have utility companies who won't share their information because of sensitivity. So you have obstacles to overcome to collect good data.
Yeah, yeah. The data should, when you use it for a project, it's been a big gripe of mine, is spend $1 million collecting all this data. Use it for the project, then it should be maintained in a repository.